Okay, so let's see what we have now. So we have while loops. Yeah, before this, I skipped a blog, like how not to use shortcut evaluation. So you just go and read it. Like, I'm not going to go into it because it's not too important, I think. You need to know if you need to know advanced stuff, a little bit of advanced stuff in Julia. But I just want to come to loops. Okay, so what are loops like? Okay, one of the loops you have seen is ripple, read, eval, print loop. So it'll read something from you, it'll evaluate, print it out, and then what to say. That's how it works, right? So this is ripple. Okay, so Julia is a ripple. So that's how it is. Okay, today is Saturday. Oh my God, another one day. That is on Monday. I should be in job. Okay, fine. Right. Okay, so you just put something over here and it reads, evaluates, sets tree, prints it out, and then it once again goes back to this Julia prompt. Okay, so this is a loop, right? So okay, so similarly, there are if you want something to do, if you want something to do again and again in programming, there are thing called loops. So I will show you. Okay, like so I'll show you one loop called while loop. There are also other loops like yeah, but yeah, I'm just going to show something like while loop. So what am I showing? Okay, yeah, sure. Okay, we just execute this example, and once done, we'll go through it, right? So we initialize I to be 1, okay, and over here the while loop starts. It's just like if loop, and there's a condition, okay. In if loop, if condition satisfies, it just runs the loop, okay, right? While loop is little bit different, okay. So what happens is, if the condition satisfies, it runs a loop, and once again it goes back to the condition, okay. If the condition once again satisfies, it goes to this loop body and so on and so forth. So, and only if the condition fails, it comes out and goes to the next state. So that's how it is. So we have I is equal to 1 and I less than 10. So first I will be less, 1 is less than or equal to 10. Yeah, it is, right? So it will just go and print I, and now I is equal to I plus 1. So, or I plus is equal to 1, both are same, right? So now I will become 2 and it will go 2 is less than or equal to 10, so on and so forth. And till it'll go till it's I is 10. Okay, I is of course equal to 10, so it'll pass and it'll print. Okay, now I will be 11 and then it'll go here, and once it goes here, like yeah, this condition will be false, and so the loop will no longer execute. So whatever you put over here, this will get executed, right? So that's how it is. So yeah, we can just see something like okay, like okay, we just put println I am done. Okay, yeah. So what happens is, yeah, this while loop keeps on going till it finishes, and then yeah, once the loop condition fails, so the condition fails, so it skips the loop body and comes to the next statement, right? So yeah, so it comes to this statement and it just prints, I am done. Okay, so that's the thing, and let's see what's next. Okay, like right. So we are seeing in this thing, we are checking out whether things are prime or not. Let me rename it. Rename. Okay. What? Okay. Right. So, like, what is prime? Okay, let's say phi is prime. Okay, not let's say phi is prime. Okay, whether we say it or not. Okay, so phi is divisible by 1 and 5. So if you divide every number by 5 that is less than 5, unless and until it is 1 or 5, unless and until it is less than or equal to 5, unless and until it is 1 or 5, it it won't be divisible, right? So we can use this property to find primes. Okay, so like if you want, yeah, you can check for prime numbers in Wikipedia. Numbers, Wikipedia, yeah. Okay, right. So like, yeah, Wikipedia would have a definition, and possibly you can learn something from here. I'm not sure, right? But yeah, like, so that's the thing. So prime number is divisible by 1 and by itself. Like 5 is divisible by 5. Okay, so when something is divisible by a number, the remainder is 0. Okay, so 5 by 1, okay, 5 mod 1, the remainder is 0. If you put any other number, it will be some other thing that is not less, that is not 0. So let's say, like, so we shouldn't start with 1 because all prime numbers are divisible by 1. Okay, so let's keep a counter called 2. Okay, right? and let's have some number. We want to find whether it's prime or not. Let's put like 17. Okay, right? Now, okay, now, what to say? The 17, okay, like number mod counter, right? Oh, yeah, definitely it won't be 1. Okay, like even if I put counter is 3, number mod counter. Okay, right. Right, so that's how it is. Okay, so yeah, so like now what we need to do is we need to increment counter. Okay, so and we need to put it in a loop. So okay, so to increment counter, counter is equal to, yeah, plus equal to 1, right? To increment it. So it'll become 3 and 4, and yeah, we need to loop. So what to do? So we need to put while loop. Okay, so we need to put while loop because that's the loop we know now. Okay, so okay, so and let's loop it till uh, okay, when it's not equal to 0, the counter will keep on incrementing. Okay, right? So that's how it happens. So like the counter will keep on incrementing, and now let's print the counter. Okay, print len. Okay, equals counter. So yeah, we put a comma and print len to separate all this stuff. Okay, so okay, now counter is 17. Okay, let me make this as 16 or something like that. Okay. Now counter is 2. Okay. 16 is not a prime, so somehow the counter is not equal to the number. Okay, so that's the thing. Now let me put 13. 13 is a prime. Counter is 13. So if you, so this makes me think, okay, counter is number when it's prime. Okay, because let's see, the prime number when divided by what to say, when divided by itself, then its remainder will be 0. Otherwise, it won't be 0. So this loop will skip only when uh, or what to say, it has been divided by, okay, only when the remainder is 0. Okay, so only when the remainder is 0, this loop will get skipped and come over here. So all we need to do is we need to check if counter is number. Counter is number. Okay, let me put like, let me just avoid braces. Okay, then println. Uh, yeah, you can press tab and you can get help over here, right? Okay. Println, okay, counter is prime, right, this put, println, okay, counter, counter is composite. Okay, so that's how it is, right? So we are making use of the fact that only if counter is number, then this condition won't be satisfied. That is in case of prime. Okay, when number is prime and this condition won't be satisfied only when counter is number. So that's it. Of course, if we put one over here, everything will break. Okay, so that's how it is. So let me put like 27. Okay, okay, so okay, and let me also print counter over here. Oh god, not, it's not counter, it's number. This both should be number, but of course, over here you can even put counter. That is over here, like you can even put counter because when this condition satisfies, counter is number. Okay, so, but yeah, the right way to do is to put number. Okay. 27 is composite. Okay, right. What to put? 32 is composite. 42 is composite, right? So yeah, this is a program to find primes. Okay, so we are doing with this thing. Okay, so that's how it is. In this example, I've just given another thing. Like if number is not equal to counter, there is a reason why I did this. Okay, like there are very few primes compared to composite numbers. Okay, so if you put like this will become more efficient. Let me tell you why. Okay, right? Let me put this condition over here, right? So most numbers are composite, like 100, something like that. Most numbers are composite. Okay, like okay, so that is composite means not prime. Okay, so mostly okay, so mostly what will happen is like this condition will fail and once again it will come over here. So that jump costs in computer. Okay, so that is in this case. Okay, whereas in this case mostly this condition will be satisfied and it will just print and it won't even bother to read this one. Okay, so little bit efficient this program in this 14th cell. Okay, we are actually called cell. Okay, so like each and everything we call this as cell. Okay, so that's how it is. And so yeah, this is little bit more efficient. Okay. Uh, so that's it about while loops. So yeah, and yeah, if you want, I can just show you like okay, yeah, I don't want to confuse more, so let it be it. Let the videos be short and sweet so that like what to say, you people understand. So that's how it is. I think in next video we'll be looking at ternary increment and ranges, for loops, possibly even breaks and continue. Okay, so that's the thing. I hope you understood. So I'll put these links and everything in the video description. So I hope you find this useful. Anyway, thanks for watching.